dear students, welcome back to my class. In the series of learning programming in C, in the previous video we have discussed about how to pass the complete array to a function. In today's video, we will continue with the same topic, that is passing array to a function, again a complete array in a different method. And we will see how that program is going to work with actual execution also. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end. Do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. In the previous video, we have seen how to pass the complete array to a function. So we pass the base address of the array. So what is base address? So base address is nothing but the address of first element. It is the address of first element. For an array, it is sufficient if we get the base address. So when we get the base address, we can simply traverse the next element because the elements are stored in consecutive locations. So how do we call the function? Say for example, I call the function say display. And in the previous program, what we did, we passed the address of the first element. So for example, you have an array, say int a with some set of values. Okay. So when we have the set of values, memory allocation will be done and say some base address 101 for the element 10, 20, it goes on. So this address we are sending a of 0. This address we will send, right? And when an address is sent in the function call, we receive that with the pointer. So in the function definition header, what we do? We say void display receive that with a pointer, right? And you have to pass one more argument to mention the number of arguments. So for example, I am sending 5 elements. Receive that, I am sending constant value. If you want to have the value to be scanned, you can also do that. So let me receive that with n. So this is in the definition header or declaration header. We receive that with pointer. Through pointer, we handled it. Right. Now, we will see in a different method. What we'll do, we will simply pass the array name. How to pass that array name and how to receive that, let us see with a complete program. This method we used in the previous program. Please do check out the playlist, you'll get an idea so that you can understand this video. So we will see a complete program like how to send the complete array and how to receive it. So here is the complete program to understand how to pass the array as complete array as argument to function. So in the previous program, what we did, we passed a pointer. So here what we are doing the declaration, just look at this function declaration. The function name is average and the return type is float. I am just finding the sum and average of n numbers using function. So array elements I need to pass to function. So if I want to pass those elements to function, I just can't pass those elements one by one. Say I want to pass 5 subject marks. So I just can't pass subject 1 marks, marks 1, marks 2, 3, 4, 5 individually. Then I have to receive that through the function individually. Maybe it may be using call by value or call by reference. But if it is call by value, memory is wasted. And if it is called by reference, it's quite difficult to handle the address of individual elements. So what is the solution for that? We go with arrays. So what we do? We simply pass the array to function. But how to pass this complete array to function? One method we have seen in the previous video. The other method is like this. So what we do here? We provide the array subscript indicating that we are sending array. So as soon as the compiler encounters this function declaration and when it checks the argument here, it gets to know that it is sending array. That is, the function is sending array. And this is same as writing a pointer asterisk. Means this particular statement will be interpreted as a pointer to integer. Means I am sending a pointer. Means in the argument I am sending pointer. This is pointer integer and this is normal integer. Right. And in the function call, declaration is like this. Two arguments, one is pointer and the other one is normal variable. And look at this. This is function call. Average, function call, that is function name, followed with two arguments. The first argument, look at here, I am passing the array name. What is the array name? It is M. So array name will provide you the base address. What is base address? I have already told you. I have told you in the previous video also. So here what we used to do in the previous program, what we did, we wrote like this. We write it like this, ampersand of M of 0. So this is same as writing like this. You can simply have the array name. When you write the array name, it is nothing but address of M of 0. M of 0 means, see here, M of 0 means it is 101, address 101. So you can simply write the array name. And this 5 indicates the number of elements. And I have given 5 elements. If you want more than that, you can scan the number of elements from the console or you can simply pass a constant value. Okay. So here we have the array name M. When we have the array name, the compiler will pass the base address. Excuse me. Base address is nothing but the address of the first element. What is the address here? It is 101. And in the function definition part, see here, I am receiving this with an array subscript. So what we think? Oh, a duplicate array will be created and all the values will be stored in the duplicate array. That we will think. No, that's wrong actually. So when we have the array subscript like this particular line will be interpreted as a pointer. It is just like int asterisk M1. So it is a pointer to integer. So when I say it is a pointer to integer, this pointer will receive that address. So what happens here? M1 will be created as a pointer and that address, that is base address, will be received here. Means to say it is pointing to the location 101. See how nicely we can understand. So if you write like this, this line will be interpreted as a pointer to integer. It is not a duplicate array which receives the copy of all the array elements. No duplicate array will be created. When you mention the array subscript like this, the compiler is going to interpret that as a pointer. It is similar to this integer asterisk, like how we did in the previous program. We say asterisk j, right? So it's a pointer variable receiving the address, and through pointer we handled the array. Here also same thing. So let us see here. So when a program gets executed, a stack memory will be created. So you have to have stack memory for main function and the sub function. So in the main function, the memory will be created in the stack memory. So we have for the array, I have written the memory allocation. So for M, the base address 101 to 110, the memory allocation will be done. So M of 0, 1, 2, 3, 4 and the elements are initialized. So I have declared and initialized. Then you have the memory for average. Then here comes the function call. So when a function call is encountered, I am sending two arguments, the array name which is passing the base address. The array, this is very important and you have to understand this carefully. The array name will give the base address. You need not again say ampersand of M of 0. If you just mention that in that way also, there is no wrong, but just the array name is very simple. The compiler understands and it will get the base address. So here M means it is array name, means to send the base address. I am sending 101 and second argument is 5. So when a function call is encountered, it will come to the definition part. So here as I said, the array name, here it is not a duplicate array, it is an integer pointer, a pointer to integer. Means it is just like this, writing like this. So M1 is receiving 101, means to say it is pointing to this. So here in the main memory we have all these values. So it is array M, and then we have average. For the subfunction average, we have many memory allocations. We have M1. M1 means it is a pointer. So it is 101 that is pointing to this location. Okay, let me use the same thing here. Okay, so 101 pointing to this location, and N is receiving the value 5. And I have sum equal to 0, initialized to 0, and average equal to 0. And for the for loop, I equal to 0. So these are all the initialization in the average subfunction, right? So whenever a program gets executed, a stack memory will be allocated. We'll talk about this memory in detail in the next video. Okay. Now we have the stack memory. The first frame for main function, second frame for the subfunction. Main function and subfunction. Now I am in the subfunction. So this is M1, that is 101, and N is 5. 101 and 5. So I think you all know how to find the sum and average of numbers. We have seen this in the previous programs and all. So I sum equal to 0, average equal to 0, I equal to 0, I less than N. Yes, N means it is 5. Condition true. Sum equal to sum plus. Sum means 0. Sum is 0. 0 plus M1. So here M1 is a pointer, right? M1 is pointing to 101. M1 of I, that is 0. It is 45. So it is 0 plus 45. It is 45. Again take a loop progress. I gets increased. It becomes 1. 1 less than 5. Yes, it goes on like this. Again 45 plus M1 pointing to 101. I, now it is 1. It is 85. So it goes on like this, and we are going to compute the sum of numbers, M of 1, 2, 3, 4, and we are going to get the sum of numbers. Say it is 45 plus 85 plus 66 plus 98 plus 77. It is something around like 371. Then again loop back. 5 less than 5, condition not satisfied, come out of the loop, control to average, average equal to sum, that is 371 divided by 5. We are going to get something like 74.2. So the average is 74.2. Then return that average. Return that average. The return type is float. Average is of float. So here one mistake I have done. Let it be AVG. Right. So it is AVG equal to 0. AVG equal to sum divided by N. So return average to the place where the function was called. So here it returns 74.2. Average AVG, this main function average is different. The subfunction average is different. They are local to the separate function. AVG is local to main function and AVG is local to subfunction. They are different memories. So for example, it is 400. Say this may have the memory as 500. Both are different. Return that value means here I am returning average equal to percentage F. Print the value, that is 74.2. So this is how we pass the complete array to a function. So here I can also write as ampersand of M of 0. This is also same. This is also same. Here I can simply write asterisk M1. But here some changes I need to do. I have to say not M1 of I have to say asterisk M1. And one more statement I need to add. I need to say M1 plus plus. Pointer incrementation. We have dealt that in the previous one. Just look at that. Just have a look, glance on that program. Okay. So here I say M1 means it is a pointer to integer. So M1 is pointing to 101, and through subscripts I access all the elements. Compute the sum, compute the average, return. This is how I pass the complete array elements to function. So let us see the execution of this. So here we have the program. So this is what the function declaration. So here we have the array, that is, this can also be replaced with asterisk. We'll see that later. So we have the array name M, and look at here. This is the function call here. The function call, we are passing the array name. The array name means it is sending the base address. Okay. So here we come to this
function definition. This is what the complete function definition. So this complete function definition, and this is what the function definition header, and M1 is receiving that base address. So here you may think that it's a duplicate array. It is not duplicate array. It is acting as a pointer to integer. It is a pointer to integer pointer, and that pointer is receiving that base address. And this, as usual, we say M1 means it is pointing to the same location. We have seen that in the dry run. So we are computing the sum of numbers. Then when the loop terminates, we find the average and then we return that average. So let us see the execution now. See, control F9. So average 30.00. Values I've given different. You can just change the value. Now what I'll do here, as I said, you can make this as asterisk. Okay, so when you make this as asterisk, and here also you can just have the array name itself, or you can just say ampersand of m of 0. This is also fine. Now what I'll do here, instead of saying m1, I'll say asterisk j. Okay, so j is acting as a pointer, and here what I have to do, I have to make it as sum equal to sum plus asterisk j, value at the location j. Then after that, one more statement I need to add up here. I say j plus plus. This we did in the previous program. So let us say control F9. There is an error. What is that error? Oh, statement is missing. Yeah, here I have missed the statement. Save the changes. Control F9. Yeah, the same thing. So this is how we pass the complete array to function. So let me change to the previous one. So we'll have brackets, and here we'll say just m array name, and here again we have to say m1 of array, so it is acting as an integer pointer. So here what I'll do, I say m1 of I, and this statement not required. Okay, so let me save this. Control F9. Yes, the same thing. So this is how we pass the complete array to function. Hope you have understood with this. The next video we will see the next topic. So take care. Bye bye. See you in the next video. Stay tuned to my channel.